Okay, thank you, everyone. We can start our webinar now. Thank you for attending. It's okay to hear me?
Yes, very clear.
Yes.
Okay, good. So today we will introduce the generate port function. As introduced last time, actually, there are many functions for the generate port. So today, first we have a brief introduction for this port, and then we can go some details on the like when working with generator and AC coupling and smart load. So let's go to the first, the generate port introduction. So first, as you can see for our 8K, 10K, and 12K, we have an independent generate port. And with this port, it's controlled by a separate relay. We can turn on and turn off it. So it's like a very flexible port. With this port, we normally in US house we have a generator backup, so we can connect a generator there. With the generator, we can also have like a seamless switch, besides the generator connection, we can also connect AC coupling. So if customer already install a microinverter system in his house, they can connect this system to our generate port as a AC coupling system. The advantage for this is like when there is power outage, both the original on-grid system and our new system can working together, which give you more power when there is power outage. So this is a very big advantage. Not also like you have two solar systems, but they can both work in when power outage. The next one is smart load. So it's like when you have some load very big, you don't want to turn on it when there is power outage. So you can put it in the generator port. When the SOC is low, then the loads will be turned off automatically as your setting. So it's a flexible port. You can do many things. There, I want to mention that. So there are three like generator connection, AC coupling, and a smart load connection. You can only use one function for the generator port. There is some application people may ask, I want to connect the generator and the AC coupling same time. So the solution we have now is connect your AC coupling system to the generator port and then connect the generator to the AC port. That means that you also cannot connect a generator and AC same time. So it's like more like a off-grid application, or if you have a ATS for the generator and grid. For this port, the hardware ability is like for the 12K, we have 19 amps relay there. So our recommend current from this port is 18 amps. So 19 amps is the maximum, and 18 amps AC current is the recommend one. This is for this port spec. So no matter you are using like generator or AC coupling, because they are both or smart load, right? So it's like the current input or output from this port is 19 amps max, and 18 amps I think is safe for running for a long time. And for the 10 kilowatt, we have 63 amps breaker and relay, and in future we will change it to 18 amps. For the version now, we recommend the current for this port is 15 amps. So it's safe for, because normally the relay spec is the maximum current. So same as the 12K, no matter you use this port as generator to connect generator or connect the AC coupling system, then do not make the current higher than this. Then With this port, we can go to some details for each function. When work with generator, actually, many people have, I think almost each home in America has a generator. So there are many functions based on the generator. We can see first, we will explain when you connect the generator, how the system works. And for some generator, we can support the generator support remote start and stop function. You do not need to turn on and off it manually. Then we also have a dry contact from our inverter. Then the dry contact will turn on and turn off the generator according to your setting. So during the startup and the stop process, we will warm up and cool down the generator to make your generator working in a good condition. Also, that in some house they may have a small generator and they want to take a little big load. In some house, if there are small generators, we can have jump boost function, which means the inverter and the generator can take load same time in this application. So it helps save the cost, help you to save the cost of the generator. You can buy a little bit smaller size for your home, and then you can use the inverter and the generator to take load together. Then the next one is also for a generator. Some people need to turn on it regularly to make sure the generator is working okay. And also there is a battery inside the generator, as my understanding. So when you turn on it, it can be also charged. So you cannot keep your generator there always not working. It is better that you turn on it regularly. So when you connect your generator to our generator port, we can also support a generator exercise. Then, as mentioned, in some application, people may both want to use both generator and AC coupling. So in this application, they may need to connect the generator to the grid terminal. So I will introduce the setting when you connect the generator to the grid terminal. The next one is also that it's very normal that people have more than one inverter in their home. In this case, the generator can also connect to the system, and there are some settings you need to note that which is the setting for the parallel system and which is for single unit. So I will give a example there. So then let's go to the generator part. The basic function. There is a picture for you to better understanding this generator port. This is a generator port, and you can see there is a relay here. So we can connect and disconnect the generator from our system according to the demands or the logic. And then we have load here. So we have load here. This is a generator relay as mentioned. The hardware ability we can go is also depends on this relay spec, and this relay can be turned on and turned off according to the logic. But you can see once the relay is closed, the generator will take the load on your load terminal, and there is also a control for the charge. So when the generator is closed, is connected or turned on, the generated power can be used to take the load and charge the battery same time. So as mentioned, please notice the spec of this relay, and then do not overload. Make this overload, this relay overload, and then it may damage it. The other thing is that do not overload your generator too. So you can see that once the generator is turned on, it take load and charge the battery, what we can control is the power of charging, because there is a charge and discharge circuit, right? So we can control the charge current, and then, but however, once the relay is closed, it will take the load. We cannot control the load. If the load power is higher than the generate power it can supply, then it may overload the generator. Then, so that's very important. In this situation, then you need a jump boost function. Yeah. So for this generator setting, the basic setting is generator rate power. As I mentioned, that we cannot control the load power because the load is a load you connect to the terminal. Once the I have recorded the training, and after the webinar, we will upload this to our YouTube. So if someone want to see it, you can go to our YouTube channel, see the webinar also. Okay, let's continue. So this is the basic settings for the generator. And as mentioned, once the relay is closed, the generator will take the load and charge the battery. We will control the charge power here. Like for example, you set your generator size is 15 kilowatt, and then your load is 8 kilowatt. Then the left, like 7 kilowatt, can be charged into the battery. So please note, this is the generator power higher than the load. If, like for example, if the load is 16 kilowatt, then you need a jump boost function. Otherwise, it will overload. And also, we will try to give you a warning if the generator is overload, as mentioned here. So if the output, if you forget and you don't know that the power, the load power is higher, although we make the charge current to our power to zero, the load is higher than the generate power, then if it's larger than 500 watts, for example, you set your generator as 15 kilowatt. However, we find the power to the load port is 16 kilowatt, last 1 minute, then the inverter will give a generator overload warning to you. Then you have to turn off some load, or you have to enable generator boost function. Also, there is generator charge current limit. So it's a limitation how much power you want from the, because you want maybe to reserve some ability for the generator. And also here, maybe we are able to charge 7 kilowatt, but you don't want to use your generator 100%, right? Then the two options, one is to you put here a little bit lower than the actually the generator can do. For example, generator can maximum take like 15 kilowatt, you can set 14 kilowatt. And the other one option is you can limit the charge current. So you the generator and take some more loads too. So this is the basic settings for the generator. And if you overload the generator, we will give a overload warning. Please also note that this is a warning. So for warning, it means we will not stop it. It will keep working. So you have to note if you need to turn off the generator or turn off some load or do something to save your generator, to help your generator. Then let's go to the generator remote control. There are two pictures. One picture is the generate port in our cable box for our 12K. You can see this is the generate terminal. And also this is the dry contact here. There is a circuit. You connect your your signal to the NO and the COM, then the inverter will control the generator according to the logic. There are some conditions where the generator, when you connect the dry contact, the logic will be like this. We will find the time you need to charge, and then we turn on the generator. So there are some situations you need to charge your battery. First is, so when there is grid, we will use grid to charge battery, take load if your battery is low, so the generator won't be start. Only when there is no grid and the battery, the first you can see that when battery reaches off-grid cut-off voltage SOC or SOC. So this depends on your setting. You can set control here. You can set control the discharge according to the voltage or to the SOC. For example, here you choose SOC, you can see the SOC is green, and you set 20% off-grid cutoff SOC. Then if the SOC is lower than 20%, the generator will be started. And also that in some application, the SOC may still high, but sometimes you know that the SOC is not accurate actually from the BMS. And for BMS, they found it, the voltage is low, then they will send a charge request to the inverter. Once the inverter get a charge request from the BMS, we will also turn on the generator to charge the inverter, to charge the battery. And also that we get some information from the BMS. If the battery doesn't allow discharge, then we have to turn on the generator to take the load and charge the battery too. The last is generators that you can set. This for the three conditions, it means the battery already goes to a very low level, but sometimes customer want to keep a certain SOC in the battery, then he can set a generator start charge voltage or SOC. So it depends also on the settings. For example, if you choose SOC, you can see here, we can go gen function part, and when you select generator, there is a charge start SOC. You may need to set this. Always people want to use this to save a certain power in the battery. So for example, if people set 20%, they don't want to go to the battery go to such a low level, then you may set the charge start SOC to like 30 or 40, 50% to save the energy, keep the energy in your battery. For this, I think people may ask, because you can see for this, you can see when you find your generator, if you don't know why your generator is start, you can check the SOC, compare the SOC to cut off SOC or start charge SOC. But sometimes we cannot see this information. People may ask. Actually, in our monitor system, we also upload this information in our monitor system in the data page. You can check this if BMS has sent this to charge request or don't allow discharge from the BMS. Also in the monitor system, when you click the battery icon, you can get more information. Let's see, we can go to our monitor system, so we can show you some settings there and where you can get this information. So you can see our my monitor page, right? When we go to maintenance, then you can go to the working mode. We can find a new, because this is not a latest version, we can find a latest version. Let me find one. So here, When you go to the remote setting, and we can go to the generate function part, there is all the settings on the generator. We just mentioned you can set your generate rated power here. And also you can set battery charge current limitation from the inverter. And there is, so also you can set the charge start SOC. Once the the battery SOC is lower than this, the generator will be turned on. And when you go back, when you go to the monitoring page, actually you can see there are some, when you can not find it, you can click the battery icon, and this information will be showed on the monitor system. So you can see there are BMS limitation for charge current, discharge current, and there is like BMS charge if charge is allowed. So as I mentioned, if the BMS is not doesn't allow discharge, then the generator will be also turned on. And also this is the request from the battery. If this is a on state, means the battery request a charge, then the generator will be also turned on. So there are some other functions I will mention later, like start gen exercise. So this is the information you can see, and then you can see why your generator is start or not. So next, let's see the generate turn off. Once the generator is turned on, the generator will be turned off in this condition. So please note that for the start, is one of the condition is triggered, then the inverter will start the generator. For the stop generator, you have to meet all the like requirements. So first, the battery voltage and SOC reaches the charge end. So it means the battery finish charge. And also the BMS do not the BMS allow discharge. So in this situation, when you turn off the generator, your battery can take, we have to make sure your battery can take your load, and the battery doesn't require a charge. So it's actually like you have to make your battery be ready to discharge. Then we can turn off the generator. So for some generator, some generator doesn't support the auto start function, then you have to start it manually. And when the battery reaches battery full, exceeds the end, there is an end SOC, we cannot turn off it. So we will just stop charging from the inverter, and the relay will be like open, and the battery will actually, like, the generator is still on. However, we will not use the power from the generator. We will use the power from the battery. So this is the remote turn off the generator. As mentioned, we also, in order to make a good condition usage of the use the generator, we have a warm up and a cool down process. So the process also is used for the remote control. We can see that there is a relay there, and there is a dry contact. So in the application, when we set a turn on signal to the generator will be turned on. However, we will not switch to the generator until 2 minutes later. So it's like we turn on the generator, we let the generator running for 2 minutes, but during these 2 minutes, the generator won't take any load and or charge the battery. It will only like empty load for it to warm up itself. And then when it goes to, when the battery full, we have to turn off the generator. Then we will first turn or open the relay, turn or disconnect the relay, like disconnect the generator from the system, and then it's like the battery will take load, and the generator will still like work, take zero load, running for a while, empty load, running for 2 minutes for default, and then we send dry contact signal to the generator, then the generator will be turned off. So it's like both start the inverter or stop the inverter. We will let the generator like working for 2 minutes without any load, and then we can take the load or turn off the generator. For the cooling down time, it is also can be set here. So the default value is 2 minutes. You can also change like 5 or like 0 minutes, depends on your generator application or recommendation. So also please note that for most of the generator function, we added this year, like generator exercise, generator warm up. So if you want to have this function, it's better to update your inverter firmware to latest version. Then you can have all the function I mentioned today. Besides the remote and warm up cool down function, we also have Gen Boost. As I mentioned, the generator is very expensive, right? And most of the time you do not need to use it. So some customer may consider buy a small generator for backup in his home. Then in this application, you can enable Gen Boost function here. Then it's easy to understand if the generate power is larger than the load power. As mentioned, for example, when you enable it, the generator power. So when you have a Gen Boost function, if your generator is still running like with a size higher than your load, because your load may change, the generator will be used to take the load and charge the battery. However, when for example, your generator size is now is smaller than the load you are using. For example, your generator is 10 kilowatt and you have 15 kilowatt load, then the inverter will discharge the power from the battery, and the battery and the generator will take your home load together. So the battery discharge is like will discharge until there is you can, as mentioned, there is off-grid EOD. Then when the SOC is lower than that, it will stop the discharge, and your generator will also in this situation will be like overload. When you enable the generator boost function, the priority of the power is that, so we will use generator power first, and if it's not enough, there is PV power, we will use PV power, and when in the night there is no PV, we will use battery and the generator to take the load to discharge to discharge and take the load together. So this is the Gen Boost function. The next one is generator weekly exercise. As mentioned, that there is for the generator, if you do not use it, if you put it in your home, and it's better to turn on it regularly and check and make sure everything is okay. So you can set a weekly exercise function here in our monitor system. You can see first you can go to the configuration, and you can go to the device. So as mentioned, first you can do a generator exercise weekly or one time here, and once you enable generator exercise, the discharge, the generator will work for 20 minutes. During these 20 minutes, if the battery SOC is lower than the end SOC you set in the web, in your monitor system, the generator will be warm up and then take the load, charge the battery. Once the battery SOC reaches higher than that, the relay will be open and stop the generator, so it will not use the generator power, but the generator will still keep working. For example, if you start charge for 10 minutes and the SOC is already high, then it will stop charge the battery, but the generator will still be on until 20 minutes. Then the dry contact will be then the dry contact will give a signal to the generator and stop the generator. Here, once the generator is started, there is a timing here, so you can know how long left, how many minutes left, and then we will turn off the generator. You can have a clear idea of what's the inverter doing. So this is a generator weekly exercise and a quick exercise. Then, as mentioned in some application, you may need to connect the AC coupling system and the generator to the system together. In this case, you can connect the generator to grid terminal and AC coupling to the to the generator port, and then you need to enable microgrid here. So once you enable microgrid, we know that the generator is connected to the grid terminal, and so the logic is same when you connect a generator to a grid terminal with a generator connect to the generator port. When you enable microgrid function, so we will also use the generator from the grid terminal to charge the battery and to take the load. The next one is when you are connecting the generator to a parallel system, then please note there is a generator power. So this is still means the generate power. So it means the whole system you can use from here is the setting. For example, if you set 10 kilowatt, then it means all the inverter together can use 10 kilowatt from the generator port. And then for the charge limitation, because you may connect the battery to each inverter independently, then this charge means for each single unit, you can, for example, you can charge 16 amps, the charge current from the generator. So this is for single unit setting, and the generate power is for the generator. So it's the whole system power we can use from the generator. So that's all for the generate port connected to the generators. Let's see if you have any questions. We can have a short discussion here, or if you want me to show you some setting or something, we can do that. So if anybody has any questions on the generator connection, actually there are some functions, as you can see. You need to make the right settings to make your inverter and generator working in a good condition. Also, okay, then if you do not have any questions, we will keep the next, go to the next part, AC coupling. The AC coupling function is easier than the generator. There are not so many function or settings as the generator part. So for the AC coupling, as mentioned, it's like you have an on-grid system already, and you want to connect your on-grid system to your microinverter to our hybrid. Then you can, in this situation, you can enable AC coupling and connect your original AC output to our generator port. There are three settings. One is enable, disable, so it's easy. If you connect the existing solar system to our system, you have to enable it. And then there is a AC couple start SOC or AC couple stop SOC and SOC. So the start SOC, please note, is that when the SOC is lower than the start SOC, then we will turn on your AC coupling system. And then when it's higher than the end, then we will turn off. It means that when we find the SOC in your battery is not enough, it's lower than the start, we turn on the on-grid or micro system. Another is frequency shifting, which is always mentioned in the AC coupling system, because there is a situation that there is no grid. The inverter, the on-grid system is connecting to the hybrid system, generating a lot of power, more than the load and the battery can use. For example, now the on-grid system is generating 10 kilowatt, but the battery is already full and they don't need any more power, and your load is 5 kilowatt. So there is extra power from the on-grid system. We cannot handle with it. In this situation, we will like shift the output frequency, and then when the frequency increase to a large value, the on-grid system will derate. So this keep a balance in the whole system to avoid more like over voltage or something. When connect the AC coupling system to the inverter, we can considering the AC coupling system and the PV is the same thing. So in self-consumption mode, you can consider the AC coupling power and the PV power. Both the power are very similar, and so they will take the load first and then charge the battery and last to feed into the grid. So this is when there is grid, then can feed into the grid. So you can just consider this power can be used same way as the PV power connect to the inverter itself. And for the PV charge priority, the AC coupling power will first used to charge the battery, and then it will go to the load, and last it will feed into the grid. So actually it's like when there is grid, you can consider this PV and this PV, they are all PV power. So according to your setting, they were either used to take the load or either used to charge the battery, depends on the setting you do in the working modes part. That is on-grid, because for on-grid, you can feed the power into the grid. And for the off-grid, as mentioned, whether we can see some, if customer, there are two settings, start up SOC and end SOC, as I showed in the monitor system. There is like 80% as startup and 99% as end. So when the battery SOC is lower than 80%, we will connect the inverter, the AC coupling system to our system. So as showed, there is a relay. We will close the relay. Then the AC coupling power can go to the inverter. We can see that here in the in this system now, if the SOC is like very low, you can see. So it start the AC coupling system. The AC coupling system is 3 kilowatt, and the PV system, the PV from the connect to the hybrid inverter is 5 kilowatt, and the load, if the load is 10 kilowatt, then the system power is not enough. They will use the PV power, the AC coupling power, and the battery power to take the load. So there are some applications that if, for example, if there is no load, the AC coupling 3 kilowatt and 5 kilowatt will both go to the battery to charge the battery. So once the SOC is higher than 99%, for example, when the battery gets 100%, then the inverter will disconnect the AC coupling system to the hybrid system. So when there is, as mentioned, there is another situation. For example, the PV power is 6 kilowatt, and we have 2 kilowatt from the AC coupling system, and then we will take load 3 kilowatt first, and there are extra 5 kilowatt. We will charge the battery. Once the battery can accept a 5 kilowatt charge power. However, if the battery is full, then there is extra power from the PV, right? Then we will shift the frequency to make less power from the AC coupling system. Then the whole system can get a balance. So this is on-grid, the AC coupling like on-grid. This is on-grid application. Then it's easy. You have more, if you have more power, you can feed into the grid. In the off-grid application, it's like we will also use the system to take the load, charge the battery. If the battery is full, or if the we will increase, make the frequency shifting to limit the AC coupling. And when the SOC is higher than your setting, we will also disconnect the on-grid, the microgrid system or the existing system. The last one is a smart load. So for the load, since it's just a load, if you want to connect your smart load to the generator port. So first, because mentioned for the generator, we have many functions. You can connect generator or AC coupling system or smart load. So when you connect a smart load, first you have to enable it. And for most of the customer, because they want to disconnect the load when there is no grid, right? For if there is grid, actually the smart load, you can use the grid. So for some customer, they want to keep the smart load always on, then you can enable the grid always on. It means when there is grid, no matter what's the SOC, the smart load will always be powered. And then if you disable it, then it will be similar to an off-grid application. In this situation, you can set smart load start SOC and end SOC, and also start PV. So when the PV is higher, for example, you set 10 kilowatt or 5 kilowatt here. So when the PV power is higher than the start PV power, and the SOC is higher than the start SOC, the smart load will be turned on. And then for example, go to the afternoon, there is little sunshine, and the battery will discharge to take all the load. And in this situation, when the battery discharge to a SOC lower than the end SOC, then the smart load will be turned off. Yes, so as mentioned, if you enable grid always on, when there is grid, the smart load will be always turned on, no matter what the SOC is. And when they're in off-grid application, so we will see the PV power and also the SOC. Only the PV power is higher than the setting, and SOC is higher than your start SOC. The smart load can be turned on. Once the SOC drops below the end value, then the smart load will be turned off. So that's for the smart load part, and that's all for the generate port function. So let's see if you have any questions.